The rate of a reaction is affected by the temperature and concentration of reactants, pressure if gases are involved, and the use of catalysts. We can plan investigations to find out how each factor affects rate. For example, plan an investigation to find out how concentration affects rate of reaction. The first method of comparing rate of reaction is to use a change in colour or turbidity. This just means the clarity of the liquid, so whether it's clear or cloudy. One way to do this is using the disappearing cross reaction. This is the reaction between sodium thiosulfate and hydrochloric acid. Whenever you hear sodium thiosulfate, you should immediately think disappearing cross. The reactants are initially clear and colourless, but as the reaction produces a solid yellow precipitate, they turn cloudy. The faster they go cloudy, the higher the rate of reaction. To carry out this reaction, we draw a cross on a white tile or a piece of paper and place a conical flask over it. We add the sodium thiosulfate and hydrochloric acid, which are both clear and colourless, and start a stopwatch. As the reaction occurs, the reaction mixture turns cloudy and yellow. Eventually, we won't be able to see the cross anymore. It has disappeared. At this point, we stop the stopwatch and record the time taken for the cross to disappear. This is our dependent variable. We can then repeat the experiment using a different concentration of acid or sodium thiosulfate. Concentration is our independent variable. The faster the cross disappears, the higher the rate of reaction. We can calculate a value for rate of reaction by doing 1 divided by the time taken for the cross to disappear. For example, if the cross took 16 seconds to disappear, we would do 1 divided by 16, so the rate would be 0.0625. To make sure our results are reliable, if we're changing the concentration of one of the reactants, we have to keep the concentration of the other reactant the same. We also need to use the same volume and temperature of each reactant and make sure the cross is the same colour and thickness. These are our control variables. A limitation of this method is that it's subjective. Deciding when the cross has disappeared is influenced by people's opinion because people's eyesight can be different. A less subjective way to investigate rate of reaction is to use volume of gas produced. This method only works for reactions that produce a gas, such as metal and acid reactions, which produce hydrogen, or metal carbonate or marble chips and acid, which produces carbon dioxide. The reaction is carried out in a conical flask, with a delivery tube connecting the flask to a gas syringe. As gas is produced, the plunger in the gas syringe moves, and you can measure the volume of gas that's produced in a given time, such as 1 minute. The volume of gas produced is our dependent variable. We can calculate the rate of reaction using rate equals product formed over time. For example, if we produced 40 centimetres cubed of gas in 1 minute, which is 60 seconds, rate is equal to 40 divided by 60, which is 0.67 centimetres cubed per second. We can then repeat the experiment using a different concentration for one of the reactants and see how this affects the volume of gas produced. The higher the volume of gas produced, the higher the rate of reaction. An alternative method for measuring the volume of gas produced is to fill a measuring cylinder with water and then invert this over a trough of water. We line up the delivery tube from the reaction vessel underneath the measuring cylinder so that any gas produced in the reaction will rise up the measuring cylinder, displacing water from it over time. We can then measure the water displaced, which tells us the volume of gas produced. This is also a good way to collect the gas so that it can be tested. These methods are less subjective and more objective than using a change in colour, because measuring the volume of gas produced isn't influenced by the experimenter's opinion. Here are some practice questions for you to try. Pause the video and give them a go. The two reactants used in the disappearing cross reaction are sodium thiosulfate and hydrochloric acid. As the reaction progresses, the clear and colourless reactant mixture turns cloudy and yellow due to a precipitate forming. If the student changes the concentration of hydrochloric acid, they'll need to keep the concentration of sodium thiosulfate the same, as well as the volume of both reactants and the temperature of both reactants. A limitation of the disappearing cross method for comparing rate is that it's subjective. It's influenced by the experimenter's opinion on when the cross has disappeared. Two ways that we can measure volume of gas produced are to connect the reaction vessel to a gas syringe, or to connect the reaction vessel to an inverted measuring cylinder and measure the volume of water that's displaced.